Hi students, Mr. Metelsky here, and this video will focus on finding the area of the shaded region in this picture. And the most important thing when you're trying to formulate a plan is to understand really what the picture is made up of. So if you look at this picture, triangle PQR, it is an equilateral triangle because all sides equal 16 units. Then it sort of looks like it's made up of these three parts of circles, and remember we call those sectors. So like the sector DPF and sector DQE and sector FRE. So we want to formulate a game plan, and I like to write that out. So here's what we're going to do. Our first step is we are going to find the area of the equilateral triangle. Okay. Then, after that, what we're going to do is we're going to find the area of one of these sectors. So this part in red here. I'm going to try and find the area of just that thing. So that's step 2. Find area of one sector. And then our last and final step, step 3, is we're going to find the shaded area. Okay, so now we at least have a plan of attack. So step 1, we're going to find the area of the equilateral triangle. Well, the formula, which you can find in the lesson for an equilateral triangle, is 1/4 times the side of the equilateral squared times √3. So, in our case, the side is 16. We have to look at the entire side. So it's 8 plus 8 or 16. So what we're going to do is 1/4 times 16 squared times √3. Now, we know 16 squared is 256. If you need your calculator, go ahead and do that. So we have 1/4 times 256 times √3. And then let's do 1/4 times 256. So 1/4 is really 0.25. So 0.25 times 256 is 64. And the √3 just comes along for the ride. We're not going to multiply those two together to get a decimal, because then it's not exact. So we know the area of the equilateral triangle is 64 √3 square units. Now, step 2 in this process, we're going to find the area of one sector. Well, if you remember, the area formula for a sector is whatever the angle is over 360 times pi r squared. Because after all, we're looking at a portion of a circle. Well, the angle isn't given. And the angle that I'm referring to, folks, is the angle in here, right? And if it's an equilateral triangle, all of those angles should be the same. In fact, from our studies, we should know that each of those angles, if there's 180 degrees, and there's exactly 3 equal ones, that they should be 180 divided by 3, or 60 degrees. So we know that the measurement here should be 60 degrees. So when I go and I plug it into my formula, it's going to be 60 over 360 times pi times the radius. Now, if we're just looking at like the red shaded circle, the radius is going to be 8 units. So we're going to do 8 squared. Now, 60 over 360, if we try to simplify that, 60 goes into both of them, right? 60 goes into both of them. So if we simplify 60 over 360, that should be 1 over 6, because 6 over 36 is 1/6. So 1/6 times pi, and 8 squared is 64. Now, when we do 1/6 of 64, because we're going to keep this in terms of pi, if we do 1 divided by 6 and times it by 64, we're going to get 10.66666 repeated. That's really 10 2/3, which is really 32/3. Okay, so again, that's 1/6 times 64, that's 32/3 pi. Now, that's the area of one of those sectors. You have to keep in mind, though, that we have 3 of them, and we're taking them away. So in order to find the area of the shaded region, what we're going to do is we're going to take the equilateral triangle and subtract 3 of the sectors, because there's 3 of them. So the equilateral triangle, that was our measurement here. That's 64 root 3. Minus 3 of the sectors. Well, that was this measurement here. So 3 times 32/3 pi. Now, if we clean this up a little bit, 64 root 3 minus, doesn't the 3 over the 3 really cancel? So we're just left with 32 pi. And we could get a decimal approximation for that, or we could leave it in this format. Oftentimes it's left in this format because this is the exact form. But if we do get a decimal approximation and we do 64 times root 3, and then we subtract off 32 times pi, using 3.14 times pi as pi, we get 10.37 square units. Okay? So again, when you're faced with a problem like this, it is complicated, but I mean, that's the overwhelming news. I mean, it tends to be complicated, but the good news is that it's just multiple steps, and if you break the complication down to little workable parts, it should be manageable, like finding the area of one triangle, then finding the area of one of those sectors, Those are concepts that we should be familiar with. Then the last step, of course, is finding the shaded area, where we have to subtract, knowing that we have 3 of the sectors and we subtracted from the equilateral triangle area. All right, good luck.